Hi, what's your name and what's your role in the project?
I'm Jan, and I did the real-time computed audio.
Marco, machine learning.
I'm Manuel and I did the embedded system part.
Riccardo, software engineering.
What would you take home from this?
Our fishing rod, of course.
All started with a big dream of us, simulate the fishing experience through multisensory interaction and a tangible object, our fishing rod. This was perfect, especially because we were operating in the field of multisensory interactive systems.
Here at the DZ department, we were looking for an interesting challenge, technically and academically. That's why we chose fishing.
Fishing has been chosen as a complex activity that requires skills such as sustained attention, reactivity, sensitivity to stimuli, up to the more abstract ones, like establishing a dialogue with an independent opponent, the fish. Even if the fisherman can speak only with the rod, the dialogue that he will create with the fish, attracting, deceiving, frightening, will go beyond the single moment of a rod shake.
For us, this fertile ground meant academically demonstrating an exciting consequence of integrating multisensory interactions, the super-additive effect.
By defining different combinations of sensory modalities, including sight, sound, and haptic, activated for distinct gaming experiences, we assess disparities in both perceived and computationally assessed performances. Our expectation? To witness a dominance in performance across all criteria when all modalities are concurrently engaged.
Could this have been the same for interaction of higher level of abstraction like ours? We aim to answer the question through experimentation, but first, let's enter in the design phase. Designing the system for us meant brainstorming, sketching, and address a critical aspect of our creation. The senses engaged in fishing and their interaction should have been simulated realistically, to take advantage the most from users' potentially existing mental models about fishing, while avoiding conflict with the latter. Concurrently, we prioritize designing strong interface for input-output modules. This in order to guide the implementation of redundant modalities in a way that the overall experience would have been robust to the condition of 2 modalities instead of 3. Last but not least, we cared about engagement and immersiveness, not only to facilitate the sustained attention necessary for a multi-phase activity like ours, but to have fun exploring a wide range of multisensory technologies and machine learning algorithms. Now, let's talk about implementation. Which activity have you done that you think are interesting?
I wrote scripts in Arduino language to govern the sensors and actuators, such as the rotary encoder, the accelerometer, and the motors. For the latter, the procedure was, I will say, complex. It required us to craft and test our own motor's physical drivers.
Considering the context in which the project was born, processing was the choice for the language with to realize our model view controller architecture. I continued shaping the scene, solving problems about missing quaternions in 3D rotation, modeling the digital twin of the rod with a physical engine dock, and defining an AI for our bot to make it responsive to the bait's movement. Luckily, in the same semester, I was attending another class, Advanced HCI. The professor provided us a great tool, OpenFace 2.0, which I use to implement the face recognition to guide the camera movements.
As a result of the tools and libraries discovered in the Multisensory Interactive System course, I knew my way around the pure data environment. So I jumped into researching and crafting true-to-life sounds, but also with enough expressivity to deliver our game feedbacks. Lastly, I used Ultimaker to make a 3D model of the reel, perfectly fitting the rotary encoder's pivot.
We are at the University of Trento FabLab. The project code-based and the communication between sensor and the system are taking shape. Now it's time to get our hands dirty. But pay attention, we are not supposed to mess with this stuff.
Hi Manuel, what are you soldering here?
I'm soldering the ESP32 can with this piece of wires.
Yes.
What are you doing, Ian?
I'm setting up the printer to print the reel.
To recognize the movement of the road, we decided to rely on a tiny machine learning algorithm which takes as input the data coming from the accelerometer, which is posed on the top of the road. In this part was crucial the training of the model. We decided to collect a lot of samples in order to maximize the generalization of the model.
Good morning, Marco.
Morning,
Good morning.
Riccardo.
Would you like to show us some performance game of yours?
Yeah. So now I'm setting the data. So here in the box I enter my name. Okay, and then I select all the three modalities.
Perfect.
And then I start playing the game.
Right now the scene is dark and the music has just one blind instrument. That means the intentionality of the fish is 0. It's the start. Now Marco will need to make some long attracting shakes to attract the fish. Can you hear this sound? Exactly. This is the sound of the shake as a feedback of the system. Now the scene is getting brighter. The music is increasing with instruments and the fish is getting closer. And here we go. Bite the fish, just tasting it. You can hear it, you can feel it with the vibration in the handle of the fishing rod. When Marco here, in the same moment the bait, he needs to perform a strong hooking. In this case, it was too slow. Indeed, the fish got scared, and the intentionality decreased suddenly. And when it's the point, exactly that. The fish in this moment is hooked, tangled to the wire. Marco will need to retrieve the fish by rotating the reel, but paying attention, because while retrieving the wire, the fish might swim in the opposite direction and accumulate damage because of the tension in the wire. In this moment you can hear it as a sound, as the color of the wire, and also in the tension as a vibration in the handle. When the fish is swimming up is the time. Yes, now to retrieve the wire and eventually hook the fish and capture it. Bravo, Marco.
Thank you, Riccardo.
We just saw Marco playing with all three modalities. But how will our participant handle the experiment with just 2?
Very difficult.
We conducted an experiment with 18 participants. We asked them to sign a consent form for the data collection. After that, each participant should play 4 rounds, the first with all modalities and the remaining with a different combination of 2 modalities. The outcome was simply great. So, can I ask you now, what are your feedback for the experience that you had?
I think that the most fun is the part in which I can feel the fishing that's gone good, and and so it.
Fabio, can you give me a feedback?
Yes, it was a good experience because I've never went fishing, so thank you. And I think it can be used also for blind people to learn how to fish.
It was quite an hectic journey, but at the end we managed to convey the product. Trust me, it will not go in the attic. We have too much fun playing with that. We end tired, but also very grateful. That's why we thank the University of Trento and its FabLab for hosting us. And invite everyone that is interested in the project to connect with us via LinkedIn and GitHub. Thank you for watching.